Hi, in this lecture we are going to take a look at finding limits by using rules of algebra. So here's a title, Finding Limits Using Algebra. So we have learned how to look at a picture and figure out what the limit is. We have learned about the concept of the limit a little bit. Now we want to know what if we want to do all of these things from point of view of algebraic operation. Let's take a look at some examples here. Let's start by a simple one. Find the limit of x squared plus 5x plus 4 divided by x squared plus 3x minus 4 as x approaches minus 4. Typical problem where you have a rational function, ratio of two polynomials, and you are being asked what happens if x approaches minus 4. First thing you go ahead and try is to see if anything very particular actually happens at minus 4. Minus 4 itself, what happens? If you attempt to plug minus 4 in this expression, you get the following. It's minus 4 squared plus 3 times minus 4, and again another minus 4. What is that? Well, that is 16 minus 20 plus 4, and here is 16 minus 12 minus 4. On the face of it, we are facing 0 over 0. So it's totally meaningless to go ahead plug minus 4 in this expression. What we mean by that is that it's not even defined. So this tells us we have to go look for plan B. 0 over 0 is not a number, cannot be described as a limit. The standard approach to these problems is to use factorization. So here's a solution by factorization. Essentially, this 0 over 0 means there's a culprit in the numerator and has an accomplice in the denominator that causes that. If you remove that, the rest of the problem most likely will be just as normal as any other problem. So I go ahead and start to say x squared plus 5x plus 4 divided by x squared plus 3x minus 4. What is the factorization of this? Easy factorization. X plus 4 times x plus 1. Denominator is also x plus 4 times x minus 1. Would have been good for you to guess this before I did it, but here we will go ahead. You notice this common factor. And notice when you put this minus 4 in these common factors, they both become 0. That is the cause of this 0 over 0. It's this factor that's creating that situation. Of course, in any kind of simple algebra manipulation like this, you go ahead and cancel these two out. And then you say what we are left with is x plus 1 over x minus 1. Technically, we have to say a little bit more. This is not really all same as that. This is same as that so long as it was legitimate to cancel them. And it is legitimate to cancel these guys if they were not 0. And they are not 0 if x is anything other than minus 4. So here I say for x different from minus 4, for x different from minus 4, this is same as that. Now, when we are taking a limit, we don't insist on going straight to the last point. We're just coming close to it. So when I am taking a limit, I can say limit of x squared plus 5x plus 4 over x squared plus 3x minus 4. If you want to take a limit of this when x is going to minus 4, you might as well take the limit of this one when you are going to minus 4. Here still x goes to minus 4. Now you can apply limit laws or anything else. When x goes to minus 4, x plus 1 goes to what? Goes to minus 3. And this one goes to minus 5. And since we are not dividing by 0, the ratio tends to minus 3 over minus 5. Let's write it. Minus 3 over minus 5, which better to be written as 3/5. So at the end, what do we say? We say x coming close to minus 4 makes this minus 3. X coming close to minus 4 makes this come close to minus 5. So the whole expression comes close to this. This is a destination, and that would be our final answer. So one standard approach is to go ahead use by factorization. You can always get a clue as to what the factor is going to be. If you have a hard time with the factorization itself, x minus the destination, like here x minus minus 4, shows up as a factor in numerator and denominator. All simple problems are like this. If you have a 0 over 0, then x minus the destination shows up as a factor. Of course, this was a straightforward problem. Many other problems are substantially more complicated. Here, let's take a look at the following. Find limit of x cubed minus 1 over x squared minus 1. Here's a fraction line. Maybe I should use a different color. As x going to 1. Now let's see if we got a lesson from the previous example. Both of these have to have a, well, let me back up a minute. If I plug 1 here, I get 0 over 0. That indicates there's a factor that needs to be canceled. What is that factor? It's going to be x minus its destination. Both of these have a factor of x minus 1. With the denominator, we are more familiar. X minus 1 times x plus 1. With the numerator, maybe you need to pause for a minute, think it out, and come back and tell me what is the factorization of this thing. Standard topic in college algebra goes through that. Okay, I hope you paused and came back. Here is the answer. It goes with x minus 1, and the second term is x squared plus x plus 1. If you didn't pause, do yourself a favor, go ahead and multiply these things out to see what's the magic that makes it to be the same as that. As in the previous problem, there is a common term that gets cancelled out. Now we get this is the same as a limit of x squared plus x plus 1 over x plus 1 as x approaches 1. Now apply the limit laws or the shortened limit laws. When x comes close to 1, this is 1 close to 1, another 1, here's a 1, here's another 1. It all tends to 3/2. We couldn't do that here. If you plug the 1 here, you get 0 over 0, and that is not a real number. So here's our answer. So we went through 2 examples by factorization. Let's quickly take a look at some similar cases, but slightly more involved. Here's another one. Find the limit of square root of say 4 plus h minus 2 over h as h goes to 0. Again, if you just take h and replace it by 0, you get, what do you get? Square root of 4 minus 2 over 0, which is 0 over 0. If it made sense, it would be just 0 over 0. So that tells us you cannot go ahead and evaluate. That is not the point of a limit anyway, and in this case it doesn't even give a sensible answer. What is to do in this type of problems? One topic you might remember from college algebra, which was the topic of rationalization. So here's a solution by rationalization. How does that go? You go ahead, you go ahead and take your expression. Here's 4 plus h minus 2 over h. You multiply it by the conjugate of the term involving your radical. Now, this only applies to an extremely simple problem. We are not saying that every problem with a radical has a solution like this. If you have difference of two items, at least one of them being radical, this approach that we are taking right now will work. What is the item we have to multiply it with? Let me write it more properly here. That is what problem I'm starting with. I take it again. Multiply it by an expression which has the same thing in numerator and denominator, and it's going to be so-called complex conjugate of this, the conjugate of this thing. The conjugate means instead of subtracting, I'm going to add them. So here, so again, where did this come from? This is same as that, except that the subtraction has been converted to addition. Why is this same as this complicated thing? Because this fraction, really, this whole thing is just 1. This is equal to 1. So I am taking that, multiplying by 1, therefore I haven't changed anything. But it's going to change the look of it. How is that going to change the look? You have to remember the following identity from college algebra again. If you have a difference of two things, multiply by the sum of the same two things, you get the difference of the square of those two things. Remember that? Okay, here is my A. Here is my B. I'm looking at A minus B. Here I'm looking at A plus B. Okay, so this is, again, this is just my A, this is my B. So when I multiply them, I'm going to get A squared minus B squared. That is 4 plus H, whatever it is, squared, minus B squared, which is 2 squared. Denominator, I don't have anything to do, and to make sure that things stay in their places, I put this denominator in one parenthesis or bracket. What do I get out of making my life complicated like this? What I get out of it is that when I square the radical goes away, I'm left with just a radicand, just 4 plus h, and this is just 4. Denominator, I still have h times radical 4 plus h, and then I still have a 2. So I'm going to, this is setting this aside as a reminder, and we continue. Numerator simplifies to an h, denominator is an h, and we have radical 4 plus h plus 2. Next, this is the place where the cancellation comes in. Here's my h is cancel. Here's just 1 and 1, and what I get here is 1 over radical 4 plus h plus 2. So when is it legitimate to cancel the h's? So long as h is not 0, it's legitimate. What have we achieved? We started with this, we simplified it, made it look like that. So if I want to take a limit of that expression, I might as well take the limit of this expression. What's the advantage? The advantage is that this one is not going to show that a 0 over 0 behavior that this one did. So let's go ahead and write this. I had my original problem was to figure out what's the limit of radical 4 plus h minus 2 over h as h goes to 0. So long as h isn't 0, this expression is same as this purple one here, and so I might as well use that. And once again, what's the advantage of using it? Let's look. When h goes to 0 here, 4 plus h comes very close to 4. Square root of that will be very close to 2. That plus 2 will be very close to 4. The fraction is going to be very close to 1/4. So that 0 over 0 that we saw over there is no longer present because the culprit got cancelled out. And here is your solution. So that limit turned out to be 1/4. Okay, now you go ahead and solve the problems I assigned from this section. I assigned about 20 problems of this nature. You take a look at that. We still have other methods to learn. What we learned today was factorization and rationalization. You go ahead and practice these. Good luck and God bless.